Hello everyone. In this tutorial, we are going to learn what is polymorphism. Polymorphism is the third pillar of object-oriented programming after encapsulation and inheritance. It allows objects, method, properties, and operators to behave differently depending on the context. We will understand how they behave differently depending on the context shortly. We have two types of polymorphism. One is compile time and the other is runtime. Compile time polymorphism is otherwise called as static or method overloading. In this type of polymorphism, we will have multiple methods with the same name inside the same class, but they differ in number of parameters, type of parameters, and order of the parameters. In runtime polymorphism, we will have the same methods with the same signature, but a different implementation inside the derived class. We will understand runtime polymorphism in details in our next video. For now, let us understand how compile time polymorphism works. To understand compile time polymorphism, I have created a simple console project, and inside this project I have a calculator class and add method. You see multiple add methods, but they differ in signature. For example, if you compare these two methods, the first method takes two input parameter as integer, but the second one takes the input parameters as double. And one thing you need to consider is the return type of the method doesn't participate in compile time polymorphism. To understand this, I have added one more method with the same two input integer parameters, but it returns a double value. But if you see, the compiler is not allowing us. It's saying that the calculator already defines a member called add with the same parameter type. So it doesn't consider even if you have a return type of double here, but return type of integer here. It only consider the type of parameters in these two methods because both of them are of type integers. So it doesn't allow us to overload this method. So let me comment it again. So these two methods, the type are different. And if you see these two methods, the order in which these types are passed is different. In the first, this ARM method, the first parameter is double, but in the second method, the first parameter is integer. It is allowed to overload if we have the order of the parameter, order of the type of the parameter is different. See, first one is double, second is integer, first is integer, second is double. It's allowed to overload. The last is we have three input parameters as integer. So now we understood what are type of parameter, order of parameter, and number of parameters. Let me change it to calculator. So what I have done is I have created a calculator reference and it's pointing to calculator object. So in this case, it should call our add methods depending upon the input type that we are passing from the main method. So the first call should go to the method having two input integer parameters. Okay, you see the first method call goes to this one because we are passing two integer parameters. The second should go to the method having two double parameters because we are passing two double parameters. Next one should be to the method having first parameter as double. So we are passing first input as double and second as integer. So it goes here. Next one should go to the method having first input parameter as integer and second as double. So if you see, we are passing first input parameter as integer and second as double. The last one should go to the method having three input parameters as integers. So now how do we confirm that this is happening at compile time? So for that, let me do one thing. Let me point the calculator to scientific calculator class. So what I have done is I have created a scientific calculator class which is deriving from calculator class, but it has the same methods with the same signature that we have inside the calculator class. So if you see here, our object reference is of calculator type, but we are creating an object of scientific calculator. This object creation happens at runtime, but this reference is created at compile time. So if I run this application, it should go to the calculator method, calculator class add method. It should not go to the scientific calculator add method. If I put a breakpoint here and run the application, you see the method call goes inside calculator class add method, not the scientific calculator add method, even if the object is of type scientific calculator, but the class reference which is decided at compile time, it's calculator. That's the reason it goes to calculator class add method. I hope now you have understood how compile time polymorphism work and the concept behind why it is called as compile time polymorphism. In our next video, we will understand what is runtime polymorphism. Thank you for watching and have a great day.